One of the most common use cases is running your Apache Spark jobs on your Hadoop cluster. Now let's do a demo of creating a new cluster and running a Spark job using Cloud Dataproc. And our goal will be to do it in 10 minutes or less, which if you've ever seen an on-premises Hadoop cluster by yourself, that seems like a pretty big win for infrastructure setup time and efficiency. Let's get started. All right, here we are in the Google Cloud Platform console. This is Cloud Dataproc. How you get here is if you open up the navigation menu. I've got several favorites that I've pinned here, but I'll show you how to actually, if you scroll down in the products and services to big data, you see a lot of the products that we mentioned so far. Dataproc is right here. If you click that pin, that'll bring it all the way up here, which saves it, which is a nice little efficiency hack. Hovering over the Cloud Dataproc service, you'll see that you can click on clusters, jobs, or workflows. But if you just click on the logo, that'll take you to the clusters page. So here we have it. It is blank slate. So the first thing we wanted to do is create and provision an Apache Hadoop cluster on Dataproc. So the configuration details, as you might expect, are here. We'll give the cluster a great name. We're going to be estimating the digits of pi in a distributed fashion, so we'll just call it pi cluster. Here you can choose what type of availability, which is essentially the ratio of how many master nodes do you want to your n worker nodes. So we'll keep it standard. If you want to adjust the hardware, which is your compute, your CPUs, you can do that here, all the way down to, at the time of recording, having 160 virtual CPUs and ultra memory. We're going to keep just standard here. And 15 gigabytes of memory, 500 gigabytes of persistent disk, sure. These are all the settings. So if you're running a pilot project for an apples to apples comparison, just map your same infrastructure that you're using for your clusters. And the number of nodes we're going to maintain at just the 2 is there. And we'll go ahead and click create. While that cluster is spinning up behind the scenes, we'll go ahead and just fill out a job to start with. So I already ran a job previously, and you can tell that since I didn't have a cluster before, that I actually turned down that cluster. So we're going to be creating a brand new job. So click on submit job. You can keep the job ID, or we'll just call this estimate pi digits. Region global is fine. It's good that we have the cluster name, even though it's spinning up. It still has it here. You can submit a job and queue it to run. Job type, it's not a Hadoop job, it is a Spark job. You can see the different job types that you could select here. And now we need to find the Java class. This is SparkPy. I'll link the example, but you can actually see there's a bunch of other Spark examples that you can run. And it essentially just, it generates a ton of pairs of XY coordinates on a unit circle, or a circle with a diameter of 1, inside of a square, which is the Monte Carlo method for estimating the number of digits in pi. If you're interested, I'll link that there, but it's essentially we're running that and using the Hadoop worker nodes to process that in massive parallel. And the actual example where the jar file is, I'll just paste that in there from the example. And we are going to generate 1,000 of those XY pairs. That's just an argument that we're passing through. This is specific to the job that we're running. Don't always put 1,000 for your arguments unless your program requires it. And we'll go ahead and submit it. Now it's going to run. Let's see if that cluster is ready for use. Yes, we have the green check mark here. If we wanted to, you can actually click into the cluster and get a lot of really good monitoring metrics that you see here. From within there, you can see the jobs that are running. In this case, for the last 30 seconds, we've had this estimate pi digits job. Let's go ahead and monitor that job specifically. Naturally, you can have multiple jobs running on a cluster, multiple clusters running multiple jobs, and boom, we get the output of our job. We see that it started here. And if we scroll down far enough, it should give us a logged output. Boom, here we go. We're actually submitted the application. And we get the result, which is the pi estimation right here. And then the job is complete. Spark has been stopped. So now what you can do is we've got a successful job execution. It took 36 seconds, plus the time to spin up the cluster. Is the real power is you can go ahead and turn down that cluster now. Now, if you wanted to have a long-lived cluster because you had persistent data on there, sure, absolutely. We'll be talking a little bit about later about the separation of compute and storage to try to get out of using persistent disks on clusters and into using something like Google Cloud Storage. But if we don't need this cluster anymore, we're not trying to persist any data. We have already ran our calculation. It's just as simple as clicking the delete icon and bring that cluster down. Don't worry about managing the infrastructure. You've got what you needed from that particular job. Or if your job's done, you want to submit more jobs or rerun the same job here. Use however many clusters, whatever size of clusters, edit the resources on the fly. The big takeaway is that clusters are now what we call fungible resources. They're ephemeral. You use them when you need them to submit your jobs. If you need them longer, or if you need them shorter, if you need more clusters or fewer clusters, you can manage that infrastructure automatically here through Cloud Dataproc. That's in essence what it is. So my challenge to you is, inside of your lab a little bit later, when you're building the recommendation engine using CloudSQL and Cloud Dataproc, experiment within Cloud Dataproc, take a look at the logs for each of your different running jobs. And if you're running on-premise workloads within Hadoop, see if you can experiment with running some of those jobs within Cloud Dataproc and see which one is more efficient.